Alright, we're going to pick up with this problem, the sodium thiosulfate problem, and like I was thinking, I'd seen this before, if this were given to you on an exam or something, I would not have you write the balanced chemical equation because it's actually not very straightforward. If you wrote it out as a double displacement reaction and worked it out like that, because I had you guess what the balanced chemical reaction was, then that's fine, you did the right thing. But the actual chemical reaction, it forms something very weird on the product side. So here's what our chemical reaction should be. Number one, you do have silver bromide, which is AgBr, and that is a solid. And then we are given our other reactant, which is sodium thiosulfate, Na2S2O3, and this anion here has a -2 charge, okay, which is why we have 2 sodium plus 1 cations, and this is aqueous. So these react, and the thing that's weird about this is that it forms this product, Na3Ag S2O3 2AQ, and this makes 0 sense to us. We don't see stuff like this. We have 2 cations in the same compound. What the heck? So you probably wouldn't have guessed that. I would not expect you to guess that. I would totally give you this reaction on an exam. Plus we should have NaBr, sodium bromide, which is aqueous. And I'm at the edge and it won't let me write. So sorry for any confusion there if you tried to work this out on your own, but here's the reaction we should have. So we need to make sure it's balanced. We have 2 sodiums on the reactant side, 4 sodiums on the product side. So we need to, I'm going to write these coefficients in with black. Double our number of sodiums, and that doubled our number of thiosulfate anions, which is good because we have 2 over here now, 2 on each side, and then we have 1 silver on both sides, 1 bromide on both sides, so we're good. It's balanced now. Okay, let's move on to the next question. Part 2, this should be a part 2. How many moles of sodium thiosulfate would be required to react completely with 0.450 grams of silver bromide? So essentially what we're doing is we are given a mass of silver bromide. So this is like chapter 6 stuff. Here's the diagram we're about to follow. We're given a mass of substance A. We have to convert that to moles of substance A. Then use a mole-to-mole ratio, convert that to moles of substance B, which is our sodium thiosulfate here, and that's what the question's asking for, moles of substance B. So we'll label this B, and the silver bromide we labeled A. So we're just going to follow this diagram. Step number 1, we use molar mass. Step number 2, we use a mole ratio. So we're going to start out with the number given, which is 0.450 grams of silver bromide. We need the molar mass of silver bromide, so we'll look that up. And that number is 187.77 grams per mole. So for every 187.77 grams, we get 1 mole, and this is AgBr, silver bromide. Okay, and then, so that's step number 1, we use the molar mass converted to moles. Step number 2, let's look at our problem, get a mole-to-mole ratio, and we see for every 1 mole of silver bromide, it's 2 moles of sodium thiosulfate. So we'll just write that mole ratio in down here. For every 1 mole of silver bromide, it's 2 moles of sodium thiosulfate. So cancel out the units properly. Grams cancel. Moles of AgBr, silver bromide, cancel. We're left with moles of sodium thiosulfate. So now we'll just do the math, which is 0.450 divided by 187.77 times 2. And you should get 0.004, I'll round, 48 moles of sodium thiosulfate. And that is our answer for this problem. Okay, the last part says how many milliliters of a 0.2 molar sodium thiosulfate solution contain this number of moles. Okay, so here we're given a molarity and we're asked for a volume. So we need the equation for molarity, which is this: molarity, capital M, equals moles of solute per liter of solution. So you will definitely, I encourage you to put this equation on your note card. It says how many milliliters. Well, we don't have milliliters in our equation, but we do have liters. And we can, once we get liters, we can convert that to milliliters. Easy enough. So I'm going to rearrange our equation to solve for liters. And when you rearrange your equation, what you should end up with, and this is just going to be algebra, I'm going to multiply both sides by liters. And liters cancel out over here. And then I'm going to divide both sides by molarity. Molarity cancels out over here. So you should have liters equals moles of solute divided by the molarity. Okay, so now we'll just plug this in. Let's go up here. Moles of solute is actually from up here, the second part of the problem. We calculated moles of solute, and that is 0.0048 moles. Our solute here is sodium thiosulfate. We're going to divide that by the molarity, which is given to us 0.02 molar. And let me write this, I encourage you to write this out in its actual units so that you see molarity is just moles per liter, right? And now when we do this, moles on top, moles on bottom, and we're left with units of liters. So now we'll just plug this in to our calculator. 0.0048 divided by 0.02 equals 0.24 liters. But the question wants milliliters, so let's convert that to milliliters. For every 1 liter, you get 1,000 milliliters. So you should get 240 milliliters of solution. There's our answer. Okay. So this bottom part, especially part number 3, was where the chapter 9 material using molarity kind of came in. All right, so we're going to move on to the next problem.